Hi, in this video I will be going to discuss about one of the sorting technique which is known as heap sort algorithm. Heap sort algorithm takes time complexity in worst case and base case, in both case big of and log n. So we have to visualize one tree because it is tree based algorithm and that tree is converted into array. So basically in screen you can see that I write here 5 elements 10, 15, 54, 20. So our first step to heap sort by the elements is by using the tree. So first step is build max heap. Build max heap means I'll tell you what is max heap. Max heap has a property which says that always the root element should be greatest in all the cases. Means if there are three elements 50, 15 and 4, then 50 should be on always in the root because it is a maximum value. So by considering this condition, and second condition is that all the childs of that particular root are in uh, indexing format, means we don't have choice to skip one element and just put the our element into the next root as a child. We have to for example, here if I draw a blank space, means I consider no element for my 50 element, means my 50 is my root, 40 is a left child, and if I consider blank space for right child, and after that I consider a 20 element for the next root, then it is not a heap. Heap satisfy two properties. First, it should be complete tree. Second, it should follow the root criteria. Means it should be max root or it should be mean root. Means minimum value should be on the root or maximum value should be on the root. So that's it. So as you see, the first element is 10, 15, 54 and 20. So 10 is root, 15 and 4 is the child of that particular root, 50 is again a second root, and the child is 20. So there are a total 5 elements. So first we do the max heap, means we swap the elements by comparing the childs and creating a max heap for each subtree. For example, here one subtree is 5420. So for that subtree, we have to consider left child and right child are smallest and the root is the largest. So first 20 is come into its place, then 15 is come into its place, and then all the elements are sorted in a fashion in which the largest element is on the top, which is 50, and all other elements which are less than that of the root are come into the next position. So that is max heap, building a max heap. Then to sort that, means we have to sort, and our main goal is to sort the array. So first we heapify that particular tree, then after that we have to delete each time a root. Here 50 is a root, so we have to delete that 50. So I'll take just a space between that and write down on the right side of that is 50. And after 50 deletion of the 50, the other elements are getting dispersed, they are deallocated, means they disqualify to the property of heap. So we have to heapify that tree again so as to get our max heap property absolute. So that's why I do here I write here do heapify. So again the elements are swap according to conditions, that is if root is there and left child and right child is there, left and right child compare each other, and whichever the greater that element, particular element left or right, go into the root place. And again we delete root, which is 20. Then there are two elements 20 and 50 are on the deletion part, and remaining elements 4, 15, 10, they are unsorted. So again we have to structure in such a way that they satisfy the max heap property. So we do heapify again. After that we delete 15. Delete 15, then we have to again heapify. That is 10 4 is the heap structure. Then we have to delete 10 and it's come to the place of initial position of the deletion tree or deletion array. And at last the null element are remaining in the tree, and all the elements which we get on the right side as you see on screen are the sorted elements. So that's it. So we have to require three function here, because as we discuss here that we require first heapify function which take array, then number of elements, and then ith index. Why ith index? Because we start the heapify function from its root. We start heapify function from its roots and compare all the elements left side and right side with the root element and then swap the elements. That's why we have to call the heapify function from root. The second function we would require here is build heap, which is basically array and number of elements. What does build heap in this case is, build heap actually call recursively heapify function and swap the elements those are not satisfy the heapify property, that is max heap property, and create a heap. And next function is heap sort, which is our main function. So it takes one array and number of elements. So these three function we require. I just declare them. We have to write down here. So first we have to write heap sort function. Then we think about how many other things we would require in this case. We'll take array as a parameter passed by reference and then number of elements. So as with earlier discussion in earlier discussion we found out that we have to heapify the, first we build heap, then we heapify the heap tree, then we delete the tree. So there are three procedure way we have to follow. So first step is build heap, which take array and number of elements. Then we have to call that for loop, iteratively go through the each and every root. So I greater than equal to 1, I minus minus, because we have to start from the root. That's why we decremented the loop. N minus 1 element is our first element and last element is our index 1. And after that we have to each time swap the element, which is array of 0 to array of I. Array of I is the largest index we found out during heapify. And then again we have to call heapify function, in this case array of I comma 0. So first step is try to build the heap, means create a max heap from the array elements. Then start from the root to the start from the end to the root. We have to swap the elements if they are not in a heapify fashion, and then again call the heapify function to arrange the elements. I use here 0 because we consider the last element as 0th index and I is our number of elements, because at each time, for example I is 3, then we have to heapify the 3 elements. That means we have to heapify the whole tree in chunks. We have to go first subtree, then again the next tree, then again the main tree. So this is how the heap sort function is work. Next we have to write heapify function. So it takes array, number of elements, and index, that is I, because we pass here index, so that's why we have to write down here index. So we require int largest, which is we point out to I. Then we require left variable, which is index of the left child, which is 2 into I plus 1, and the index of right child, which is 2 into I plus 2. This is right child, this is left child. So two child index are just generated. So we have to use here if condition. If left is less than n and array of left is greater than array of largest, then our largest is equal to left. In this case, what we do actually, we first check that whatever the index of left child and right child we are getting, that should be less than number of array elements, because if it is going of uh, uh, overflowing that, then it should get error. So that's why left should be less than n. An array of left, if array of left is greater than a array of largest, means the element which we consider as a largest, that is root, it is not largest but it is less than some of its roots. For example, left, array of left means left child is greater than largest, then we have to point that largest variable to left. That means we have to consider our left child as our largest element. And if this condition is not true, means right is less than n, an array of right is greater than array of largest, the other way around, means the right child is greater than root, then we have to assign our largest is equal to right. That's it. So first two if loops are for assigning which child is greater. If in if the both child are not present, in case, or if both child are less than that of the root, then we have to write the third condition, that is largest is not equal to I, means there are the third condition is like the root have no child, or left and right child, after comparing we found out that they are already smaller than the root. Then what should we do? Then we have to just swap our largest element with array of I. That's it. That means we are swap the array of root element with the largest element, whichever it may be. It may be right element or it may be left element. So that's taken care by this earlier if loop, if conditions. Then we have to call again heapify function. This is recursive call, because we have to again check that, because in this condition, first two conditions we check for the root element, sorry, for the end indices. We go up till upper point, that is root point. So for that we have to write here n comma largest. That means we consider largest as our call function, means we start from the element which we are already swapped. That's it. So this is heapify function. Then we have to write build heap function, which takes care about the heap. So in this case we have to generate a for loop I is equal to n minus 2 slash 2 I less than equal to 0 and I minus minus. As we go from lower position to the highest index, which is our root, so that's why this is the case. So we have to call again heapify function, heapify array comma n comma I. So in first heapify function, we recursively call the subtree into subtree into subtree. We found out that last subtree have no child. Then we go into the larger tree, then again larger tree, and at last we go found out the root, the the largest tree, which is the main tree, and we swap the elements according to that. So build if function, what it does actually, it starts from the parent index n minus I, floor ceiling of n minus I by 2, and here my arith element is n minus 1, which is last index. That's why here I started from the n minus 2 by 2, and I should be greater than equal to 0 and I minus minus, and again call heapify function. So that's it, code is ready. I again tell you what I did. There are three functions require heapify, build heap, and heap sort. So according to the procedure we discussed earlier, we first have to heapify the array, means we have to build a max heap. Then and then only we can delete the elements and we create a sorted array. So our first target is to heapify. So that's why I use here function build heap, which actually from subtree to the largest tree, it swaps the element and compare the left and right child, and then swap that right child or right child to the root, and then again call will start from that particular root to the upper side. That's how build heap function will work. And again the last function is heap sort. It first call build heap function, then the arith element which we want to delete is n minus 1, and we swap the element. Here swap means we are actually deleting the element, means we side out those elements which are already sorted or already in its original position. So that's it. So we have to check our code. So array of 5 elements, we take our example as it is, which is 10, 15, 54, 10, 15, 54 and 20. So that's it. So we call heap sort function, we pass the array, and number of elements are 5. So to print out those elements, we have to start from the loop. Cout array of I. So that's it. We have to check the code. So as you see on the screen, the elements are already sorted: 4, 10, 15, 20 and 50. We first passed here 10, 15, 54 and 20. And after doing all sorts of 3 procedures, we finally get our output as increasing order of elements, that is 4, 10, 15, 20, 50. So our code is run successfully according to the output. So that's it. Thank you for watching. Like, share and subscribe if you like my efforts. Thank you. Stay blessed.